Okay, we are going to pick up from section 2.2. So let's just be mindful that I'm going to be kind of mixing up the sections just a tad. So I have to tell you where the section is coming from. So I'm letting myself as a friendly reminder. Okay, so what we want to recall behind door number one is we talked about the derivative of a function utilizing the limit definition. And so f prime of x equals the limit as h approaches 0 of the difference quotient f of x plus h minus f of x all over h. And we illustrated that that represented the slope of a tangent line at any given point x comma f excuse me f of x. And we're going to get into some language. So if the function is differentiable, then this limit definition has to exist. So let's just kind of put that in space. And then we were finishing up our class illustrating here that in order for a limit to exist, the left-hand derivative and the right-hand derivative has to equal. And this is the thing, practicing the notation, because now the left-hand derivative is the limit as h approaches 0 from the left. And again, a could be interchanged with x. So this could be f of x plus h minus f of x all over h. And then this is the right-hand derivative. And look at the limit notation as h approaches, how do you say, 0 from the right. And again, a and x are interchangeable. So f prime of a exists if and only if these one-sided derivatives are equal. And so I'm going to pause here. Okay, so let's pick up on this example that was given in this week's discussion. So if the does f prime of 4 exist, this is a piecewise function. So therefore, we will have to evaluate f prime from the left of 4 would equal the limit as h approaches 0 from the left, f of x plus h. So from the left, we're going to use this one here. So therefore, that is going to be in the numerator a5 minus a is replaced with 4 plus h minus f of a, which 5 minus 4 is going to be 1 all over h. And therefore, you notice here that the 5's will cancel. So you're going to get the limit as h approaches 0 from the left. The h's cancel, so you get a 1. And therefore, you get a 1. Now you have f prime from the right of 4, which is going to equal the limit as h approaches 0 from the right. Now we have to evaluate from the right. So this is going to be 1 all over 5 minus, this is going to be a 4 plus h here, minus the 1, which is going to be all over h. And so now you have to build up to have a like denominator. So the limit as h approaches 0 from the right. When I combine this into a single fraction, this is going to be 1 minus this is going to be a 1 plus h. So therefore, this is going to be a 1 plus h, which is going to be all over a 1 plus h. And then we multiply by the reciprocal 1 over h. When you distribute here, the 1's cancel. And when you distribute here, you are going to get a minus h. And that minus h, what this h is going to reduce. So you're going to get the limit as h approaches 0 from the right. This is going to be a negative 1 all over 1 plus h. And therefore here, when you do your direct substitution, you'll notice that you get a negative 1. And since f prime from the left of 4 does not equal f prime from the right of 4, therefore f prime of 4 does not exist. And that would be my conclusion. So using this limit definition, it's a little bit more work involved, and we're going to get out of that in a moment. But we need to practice multiple functions of this. And so another example that I would like to kind of take a look at here is, given the following: f of x equals x squared minus 2x to the cube, find f prime using this limit definition. And so again, it's at random, so proper notation, f prime of x is going to equal the limit as h approaches 0. This is going to be, I got to put an x plus h here and an x plus h there. So this is going to be an x plus h quantity squared minus, then this is going to be a 2 times x plus h to the third power minus f of x, which is going to be x squared minus a 2x cubed, which is going to be all over h. And this is where the simplifying comes into play. So the limit as h approaches 0, when I multiply this quantity, you get an x squared plus a 2xh plus an h squared minus a 2 times, when you multiply x plus h to the third, you should get an x cubed plus a 3x squared h plus another 3x h squared plus h to the third minus an x squared plus a 2x to the third, which is going to be all over h. And then you have to distribute here, 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 and there. So you have the limit as h approaches 0 of an x squared plus a 2xh plus an h squared minus a 2x to the third minus that's a 6. A 6x squared h minus a 6xh squared minus a 2h to the third minus an x squared plus 2x cubed all over h. And so what you notice is that this 2x to the cube and this 2x to the cube, they cancel. And I also notice that this x squared and this x squared, they're going to cancel. And also what I notice here is that I have a factor of H, 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 and an H. So I'm going to go ahead and factor out an H. So then when you write that down, you have the limit as H approaches 0. This is going to be a 2x plus H minus a 6x squared minus a 6, a 6x H minus a 2h squared. And then we have a parenthesis here times H times all over H. And so the H's are going to cancel. And when the H's cancel, okay, so when the H's cancel, then you get the limit, the limit as H approaches 0, and parentheses, you get a 2x plus H minus a 6x squared minus 6xh minus 2h squared. And when you use your direct substitution, because this is as h is approaching 0, this will go to 0, this will go to 0, and this will go to 0. So therefore, you would get 2x minus a 6x squared. And f prime of x for any value of x equals this. And practice proper notation, equality, 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 and we're writing that limit notation down at each step, please. So that is one component of the 2.2, using the limit definition to compute the derivatives. Now we're going to move into some conceptualized theoretical components, which means some theorems.